So the name of this lesson is Finding Trig Ratios Given Others. Right off the bat, you can see exactly what this looks like. We're given that cosine of theta equals 2/3. The question is, what is sine of theta? Now, I remember when I first saw these problems, I thought, wow, these look really hard. How can I tell what sine is if I'm only given what cosine is? Well, fortunately, we have enough information to solve this problem. So let's go ahead and take a look at how to solve it. Now, you can easily draw a triangle from this information. Going back to what they gave us, it says that cosine of theta equals 2/3. Now remember, cosine equals adjacent over hypotenuse. So I can draw an angle in a triangle. I can label my adjacent side 2 and my hypotenuse 3, since cosine is adjacent divided by hypotenuse. So when you're given a trig ratio, you can fill out 2 of the 3 sides of the triangle. Your triangle might look different than mine. It doesn't matter. Just be consistent with where the starting angle is. So here's your starting angle, theta. Your adjacent side must be 2, meaning next to theta but not the hypotenuse, and 3, which is the hypotenuse, which is opposite the right angle. Now we just need to solve for this third side, right? And since it's a right triangle, we're dealing with trig ratios. Means we can use the Pythagorean theorem to solve for the third side. So after you draw the triangle for step 1, step 2 is to plug in known sides for the unknown trig ratio. So I guess you might not always have to use Pythagorean theorem, especially if, like, for example, in this problem, if you were trying to find secant, you wouldn't need to use the Pythagorean theorem. But so I guess that's why we do step 2 first. Sine is opposite over hypotenuse, right? So we know the hypotenuse is 3. However, we don't know what the opposite side is. So that's where we would use the Pythagorean theorem to solve. Step 3, solve for the third side, or the side that you need for sine, in this case opposite. So we'll have 2 squared plus b squared equals 3 squared. I'm not going to spend too much time on talking about all of this math. You understand it at this point. You're going to end up with b equals the square root of 5. And now that we know the opposite side is square root of 5, we can easily go back to sine and say, okay, well, the opposite side is square root of 5, the hypotenuse is 3, so therefore sine of theta is equal to the square root of 5 over 3, and that is our answer. So what we did was we drew a triangle, we used cosine and the definition of cosine to fill in what we knew about the triangle. We figured out that we needed the opposite side to figure out sine, and we did that using the Pythagorean theorem, and this was our answer. Sine of theta equals square root of 5 over 3.